Welcome back. Today we're going to talk about simplifying expressions. So an expression is simplified if it is written as an equivalent expression where all the grouping symbols are eliminated and all like terms are combined. Okay? And the definition for equivalent expressions is that they are algebraic expressions that simplify the same value for any value substituted for the variables that they contain. All right, well, what does that mean? Let's talk about it. All right, so we have x plus x. Well, if I simplify that, that would be 2x, okay? So these two are equivalent expressions because that if you put in a value, let's say that I can choose a value for x is equal to 4. Well, if I put x on the left-hand side, so if I'm evaluating for 4, I would get 8. And if I put x on the right-hand side, I would get 8. Well, it's going to work for any number that I choose for 4. And that's what makes them equivalent expressions. So they're algebraic expressions that simplify to the same value. They simplify to the same value for any value substituted for the variables that they contain. Okay? So essentially, they're equivalent if you can put any number in for the variables and the left-hand side is equal to the right-hand side. Okay. So the first thing we need to know is what like terms are. And you might have gone over this in 7th grade, but let's just go over it now again. Like terms are terms with the same variables. They have to have the same combination of variables, and each of the variables has to be raised to the exact same power. So things that are like terms, 2x, 3x, and the coefficient in front of this x is 1. Whoops. So right here, this coefficient is 1. So 2x, 3x, and 1x, all like terms because they all have an x and each x is raised to a power. Okay. All of these numbers, 1, 5, 107, those are all like terms because there's no variable that they are attached to. So these are actually called constants. We'll talk about that more when we talk about polynomials. Okay, 3y, 19y, and y. So notice that the number that's the coefficient in front doesn't have to be the same, but the values, what has to be the same is the variable, and what's implied here is that the exponent on the variable for the y here is 1. So the variable and the exponent have to be exactly the same. Now let's 5n squared, and 12n squared are also all like because you have n squared. Let's do a more complicated. So if you have 3x squared y and let's say 4x y squared, these are not considered like because the one with the coefficient of 3 has an x squared, whereas this one only has an x to the first power. And they are also further not considered like, even though if it fails once, it just fails. You know, that this one has a y to the first power and this one has a y squared. So it's not enough that one of the values is raised to the first power, one of the variables is raised to the first power and the other one the second power. In each of these terms, the variables have to be attached to the exponents have to be attached to the exact same variables in each terms. So some unlike terms, x, y, and z. Okay, 1x, 5, and 100y are unlike. 7a, 5b, and 7. 5n squared n and 12n to the third because all these n's are raised to the other exponent. Another thing that's unlike is like 6x and 6x squared. So even though the coefficient is like, that doesn't matter. The only thing that matters is the variable and its power. Okay? Okay, if we're asked to simplify the two expressions below, we're going to use the properties that we learned in the previous module, okay? Those are the properties of the associative property and commutative properties of addition and multiplication and the distributive property, okay? So the associative property tells me that I can rearrange these numbers so that I can put them next to each other. And I can put these numbers next to each other. Sorry, that's the commutative property. Okay, the commutative property says go ahead and put them next to each other. And the associative property says, well, if I have a number here and if I have a variable here and I have two coefficients be multiplied by the same variable, then what I can do is I can add the coefficients here and keep that variable the same. Okay, so I have 3 of these things, I have 2 of these things, I have 5 of these things, which are just happen to be a's. Same here, I have 5 plus 4 b squared. So it's sort of like a reverse distribution. We're going to end up later on in the year calling this factoring. So I'm factoring out the b squared. Okay, so it's reverse distribution. Instead of distributing the b squared into the sum of 4 and 5, I am pulling the b squared out. So here I'd have plus 9b squared. Now you probably already knew how to do this from last year, and you don't have to show this extra step right here, nor do you have to show this step, but it's good to know the reasons why we're allowed to do those steps using the properties of real numbers. So here I did a process called combining like terms, okay? That's what this process was called. Now to simplify the next one, I need to take note of something, okay? This expression is very different from this expression. Okay, this expression has these parentheses, and these parentheses are going to make a lot of difference. Okay, these parentheses say that the subtraction right here is applying to both the terms in the parentheses here. Whereas down here, there's no parentheses, so the only term that the subtraction is being applied to is the 3x term. Okay, whereas everything in these parentheses up here is going to be subtracted. Okay, so in order to actually go ahead and do the subtraction, I'm going to have to get rid of the grouping symbol, but I have to bear in mind that both of these things are being subtracted. So what we're going to do is we're going to distribute the subtraction into both of the operations here. So we can go, so think of it, you're taking 4x and you're subtracting 3x and you are subtracting 1. Now, what you're doing is you're sort of, another way of looking at it is you're taking a negative 1 on the outside. So think of subtracting as keep, change, like multiplying a negative 1 through to both the terms. So let me just write this here so it's a little bit easier to understand. You're taking the 4x and you're adding negative 1 times 3x plus negative 1 times 1 minus 2. So where did the negative 1 come from? Well, if you're subtracting, I can think of this as adding a negative 1 times everything that's in here. So I'm distributing a negative 1 into both of these terms. The addition in between came from right here, came from the addition right there. And this addition here came, or this one came from this one. Okay, so let's go through and do the problem here. We have 4x plus negative 3x plus this here is negative 1 minus 2. Okay, so we were going to have, right here, I can add those two together. I can combine like terms here, so that's 1x. And then if I have plus, so I have plus 1 minus 2. Now 1 minus 2 is going to be negative 1. So I have 1x plus negative 1, or 1x minus 1. So if I have the combination of plus and negative number, I'm going to change that into subtraction because it's more more simplified. And actually, I don't need the coefficient of 1 here. So the most simplified is actually x minus 1. Okay, because 1 times x is just x. So the most simplified means I have the fewest amount of symbols. I have an equivalent expression with using the fewest amount of symbols. So here, the difference between x minus 1 and 1x plus negative 1, which is what I had on this line, there's some extra symbols here. So this is an extra symbol. These two can be combined, and I didn't need this symbol. Okay, so we have x minus 1, and it's equivalent expressions using less symbols. Okay, so let's try this word problem here. We want to write and simplify an expression to answer the question below. Carlos is buying supplies for school. He buys P packages of paper at $3.50 per package, and he buys the same amount of packages of pens at $2.50 per package of pens. What is the cost for pens and pencils? Well, each package costs each package costs $3.50 and $2.50 respectively, and he buys P of those packages. So there's a couple different ways you could do this. You could say that you could combine the price of a pen, a package of pens, and a package of paper, and say that this is the cost for one package of both of these objects, right? But you're buying P amounts. This is one way of doing this. Or you can say, well, it's $2.50 for a package of pens, and you're buying P amounts, okay, plus $3.50 per package of paper, and again, you're buying P packages. So here, when you're at, these two things end up being like terms, so you're gonna end up with $6 times the amount of packages you're getting, okay? The amount of packages either for the pens or the paper, because P is the same, you're getting the same amount of packages for both, right? The same thing is gonna happen here. This is gonna be $6 times the amount of packages you wanna get. All right, so there's two different ways of thinking about it, just using orders of operation. Okay, you can add together the numbers to get the price of one package and then multiply it by the number of packages, or get each cost of the packages of pens and the packages of paper separately, and then add them together because they're like terms. And that's it. So we just use the rules, the associative, commutative, and distributive property to simplify expressions. And simplifying expressions means we get equivalent expressions with the least amount of symbols in it. So we try to get rid of all the grouping symbols, and we try to combine all like terms. Okay, and that's the end of the lesson for today.